Hey, Anthony, first things first. Sorry about being late. I just now realized that you had in your question actually requested that if it's possible that I'd please answer before such and such a date. And clearly we're beyond that date, so apologies about that. Here's what we're gonna do. I will put my email in the description of, or the message that follows along with this answer to your question. So if this answer comes too late for it to be useful for you within the context that you were asking the question, send me an email and tell me that, and I'll talk to ScaleAbout and make sure that you get a refund, right? So hopefully that turns out right. But anyways, that's the precursor. No, not a precursor. That's the prelude. Whatever. Let's get into the actual question. Okay, great question. Okay, so essentially you're asking about an IoT, like an Internet of Things kind of system. And I haven't really thought this through thoroughly, but I figured we'll just take a stab at it because I think you've outlined the issue or the scenario pretty well. So I guess we'll find, I think we'll be able to find a few useful points as we go through it like this. So let's get started. I mean, let me just try to reiterate what you've been saying. Wait, let me. Sorry, just move the screen so I can actually see it from here. So you were saying, okay, you would like to follow follow object-oriented programming principles and the solid principles, and you're building something which is like IoT-like, where you have, and this is like, I think it's called something like a noun and a verb analysis or something like that when you're doing object-oriented modeling, and it seems like you're actually already doing that, right? You're saying, okay, we're gonna have devices, we're gonna have sensors, so these are nouns. Sorry, English language. So it's basically an IoT system where devices can be controlled and sensors can be displayed and analyzed. So I should say devices and sensors, and devices can be controlled and sensors can be displayed and analyzed. Okay, that's cool. And then you were saying, you were thinking about design patterns, you were thinking about facade, command, strategy, and observer. And I think this is a great set of patterns. Like, if we just jump into it at once, I think about facade pattern as something that I apply in retrospect if I've already managed to design the inner workings of a subsystem, or let's call it a module, right? So if I've been able to wire the pieces together of something that does something complex, and then I think, okay, well, this is unnecessarily this is very abstract and very general, but it's unnecessarily complex for the person who wants to use it. So if I'm in that scenario, then I would think about creating a facade. But I think it's, in my mind, I mean, people probably have varying opinions, but in my mind, it seems unnecessarily, no, let me put it this way. It seems potentially dangerous, very much quotation marks, potentially dangerous to start in the end of a facade, right? Because then you're oversimplifying your scenario, and then you're painting yourself into a particular simplified corner, which might not necessarily be the particular corner that you want to build your abstraction in. I'm putting this in kind of a strange way, but I think you're kind of seeing what I'm saying, right? It's like, start by first figuring out how the problem needs to be solved if you solve it sort of quotation marks perfectly, and then figure out the simplification, right? Rather than starting with the simplification and then finding that when you realize what the real solution, what the perfect quotation mark solution would look like, it might be very difficult to retrofit the perfect solution into your simplification. So that's the way I'm thinking about facades. So I would push that onwards, right? And also we could put it this way. Sometimes we don't even need the facade, right? Because sometimes it turns out that the perfect solution that we're building is sufficiently simple so that the user can simply use that instead. Okay, but anyways, I mean, it's a good pattern to bring up in this context. And let's talk about strategy pattern. Like, I mean, strategy pattern is, in my mind, essentially dependency inversion, right? Or I should say dependency injection. So inevitably you're going to use it. So spot on, man. I mean, for sure, you're probably going to use strategy pattern. Okay, what are you saying? And then you're saying, okay, you're looking for some interfaces, abstract classes, maybe some concrete classes. Right, and then you were saying, okay, you were thinking about dividing a house into room objects, and then each room object have devices and sensors. And spontaneously, if we think about this, first of all, I mean, great suggestion. Obviously, great suggestion. I think this makes, like, overall, the way you've structured your thinking here, or sort of, let's say, not premature, but the initial modeling efforts, I think is great. Solid. I mean, this is a very good point to start from. Okay. Dividing a house into rooms. This is an interesting scenario where I'm not going to push towards that when we start to draw stuff now, but just think about this. It's possible that you could even use composite pattern. So, for example, I think I've talked about this I have talked about this in another video, which might be the command pattern video, maybe. In that video, I talked about how we have Philips Hue in our home, right? The Philips Hue lighting system, and and then for example, we have these controllers to control the different lights. And something that bugs me is that one of these things can control. Oh, of course, there are third-party solutions for that and all that. But I'm just to emphasize the scenario. One of these things can control a room, right? Or it can control I think like up to 3 rooms or something like that. So you can connect it to 3 rooms at the same time, or you can connect it to a single room. But I can't connect it to subsets of rooms, right? So I can't connect it to, like, I want to have like section 1 of the room and section 2 of the room, and then I want to have one controller that controls section 1, one that controls section 2, and another one that controls both, right? Then I have to make them actually separate rooms, right? Which metaphorically doesn't really make a whole lot of sense. Right? At least in my mind. So yeah, maybe you could say, okay, well, I'm just using this Philips Hue stuff incorrectly, and I should just give it up and say, okay, I'll call this like an actual room, and I'll call this part an actual room. But I would think of it this way. I would think, what if we just think about it as composites? What if we just think about a room as a set of devices? Yeah, it's a set of devices, right? Where this set of devices could be either a set of devices or sets of devices and other sets of devices, right? So you could say a room is just a section, right? So you have section A, and then you have section B, and then you have the whole room, which is section C, and section C is comprised of section A and section B. And then you could say this, the house is section D, and section D is comprised of section C, right? And section C is comprised of section A and B. Yeah, sorry, I'm confused by all the letters. But I think you were seeing what I'm saying, right? It's like we would be doing this, like, well, the house is comprised of section A. Sorry, now I'm using different letters. So forget about the previous example, right? So let's say the house is comprised of the, let's say, living room and the bedroom. Let's say, and the living room has section left and section right, let's say something like that. I mean, like TV area, sofa area, or whatever. I mean, dining area and relaxing area. Wait, is this? Yeah, it seems like you can see this. Okay. But then you could even continue this and divide it further, so that, like, the left area is divided into, like, the top left area and the bottom left area and so forth. I mean, surely. I mean, I assume that one of the reasons that they didn't do this for Philips Hue is that maybe it's unnecessarily complicated for the average user who probably isn't looking for this level of granular control. But I'm drawing this parable. I'm likening your scenario to this scenario because maybe that would be interesting for you, potentially, right? Because it depends on what you're building. Maybe you want to be able to work with sort of arbitrarily detailed sets of devices and sensors, right? Or arbitrarily aggregated sets of devices and sensors. So maybe you would look into composite pattern. Okay, but let's remove this stuff. All right. But yeah, let's get into this. Okay, so in the interest of time, I have to be super quick. So. Devices and sensors. Let's just start with this, right? Let's say we have devices and we have sensors. And in my mind, it's not obvious yet that we need classes or interfaces for these, because we're not sure what the methods for these would be, right? So let's hold on with that for a second. Let's instead just think about, okay, what would be some examples of devices? So, I mean, since we talked about Philips Hue, let's say that device would be a lamp, right? Actually, you had some examples. heating, refrigerator, vacuum cleaner, right? So let's say heating. It's called a thermostat, right? Wait, what is that? Yeah, I think so. So it seems so. Apologies if I'm getting this word incorrectly. So this is the issue of not being a native English speaker. So I think a thermostat is maybe something that can control temperature, but also can measure temperature. But okay, yeah. Sorry. No, side note. Okay, let's go back to just as you were saying. Let's call it a heater. Okay. So there are lamps. There are heaters. Maybe there is, as you were saying, there's a refrigerator. Maybe there is a I don't know, like let's say like a wall plug. What would that be called? Like a switch, right? And I don't here mean a switch as a router and a switch, but I mean as a wall plug switch, like a on-off button. Maybe there's a better word for that. Let's not think about that now. Okay. So that's that. And what are sensors then, right? Sensors are stuff that gives you data, right? So let's say a motion sensor. You were saying motion sensor, smart thermometer. I'm not sure what the smart part here refers to, so I'll just say thermometer. Meter. Okay, and more stuff. Right? Like we can probably think about lots more stuff. So initially you might say, okay, well, let's just create a hierarchy, and this is kind of like the old school object-oriented way of thinking, right? Like let's create a hierarchy where it's like a taxonomy, right? Where it's like this thing derives from this thing, which derives from this thing, which derives from this thing, and that's how we're sort of showing what things are similar. But that has a number of different problems, and I think you know that if you watched my strategy pattern video, where it's like, well, if sharing behavior like this and this is fine, but when you have to share behavior like this, you get into troubles, and maybe that's not the correct way of drawing it. It's more like if you have it's actually, maybe this is actually more accurate. It's like, well, this thing shares behavior from A and shares behavior from B. It's like it has two parents, and this thing shares behavior only from B, for example, right? Like that's another way of thinking about it. So, okay, let's do this some other time. I need to restructure my thoughts and sort of follow into the conventional way of talking about this problem. But I'd recommend Sandy Metz has some great videos on the issue of where she really explains like the issues of inheritance and why some problems can't be solved using inheritance in some sense. Okay, so what we're going to do instead is we're going to talk about interfaces. So I would say, like, let's just follow down a path and let's see where we end up. So I would say, let's figure out what's common between these different things, and then let's give them an interface, right? Let's call them something. So let's simply, I mean, a switch is turned off and on and offable, right? We need to call that something. It's called powerable, right? So let's say that there's an interface called powerable. Okay, what does that say? It says, well, you can switch on and you can switch off. You could have a switch you could have a switch. Actually, let's give it that as well. So there's a switch function as well, and maybe that would even then be abstract. So this would maybe be an abstract class. So switch already has an implementation because switch calls on if it's on and off if it is off. But then it needs to be able to inspect. Yeah, so let's get that. Let's just say on and off, okay? That's fine. Yeah, so I'm starting to realize in my mind this is a non-trivial scenario. We're probably not going to be able to fit as much stuff as I would want in this video, but let's see how far we get. So we'd have something like on and off, okay? Void methods. powerable. So this is powerable. But actually, a refrigerator is powerable, a heater is powerable, and a lamp is powerable. Cool, right? You can cut the power. Okay, so let's say we have the lamp. Yeah, actually, let me save some. I'll save time by doing this. Okay, so who inherits or who implements the interface powerable? Well, lamp, heater, refrigerator, and switch. They're all powerable. Cool. Okay, those are the devices that are powerable. Let's think about it more. Okay, so heater and refrigerator has temperatures, right? So you can set target temperature. So let's say temperable. Temperable. I am completely aware that's not a word, and if it's a word, it probably means something completely something else. So apologies for that. So let's say maybe we just have set, right? And it takes let's pretend we have a data type which is a temperature, and I'll call it T here, right? So you send some kind of temperature to it and you set that temperature. And then the question is, okay, who implements that interface? Well, actually, let me probably use a different color here because this is going to be a bit tricky to see. So temperable, heater and refrigerator is temperable, right? So refrigerator and heater. And lamp doesn't really make any sense, right? I mean, lamps are not temperable, switches are not temperable. Switch probably only does on-off, right? But what about the lamp? Let's say that we have these sort of hue lamps, like let's say we have colored lamps or lamps that support multiple different colors. So then we need to be able to control colors, right? So maybe then let's switch colors again. So let's say let's call it colorful. Colorful. So things that are colorful. And then we can say let's also here have set, but here we set, and then we'll pretend we have a color data type, so we'll send a color into the set method of something that is colorable, and this is an interface. And who implements that interface? Well, it's actually just the lamp. Okay, heaters are not colorable or colorful, refrigerators are not colorful. Actually, let's call it colorable. Color, because temperable, portable, no, powerable, sorry, colorable. Okay, so the lamp is colorable. That's cool. Okay, and then we could go on like this, and there's necessary overlap between the different things, and it's because of this overlap that we can't build a hierarchical structure for this whole problem. Okay, now let's talk about the sensors. Okay, we kind of do the same thing for the sensors, right? So the motion sensor, let's think about that. Or wait a minute, let's think about this. Do we actually do the same thing for the sensors? So the sensors need to be able to report data. And I think you were spot on when you were saying that you need to say that the sensors are observable so that you can observe, you can register observers to them, and then whenever they have new data to report, they would report that data. Yeah, so it's not obvious to me yet that we need to say that the motion sensor is of something and that the thermometer is of something, except that we would maybe say that there is, yeah, actually, so this is maybe the sensor part, right? So let's say that the sensor interface is that you need to be able to add a sensor observer and maybe remove a sensor observer, remove, just put ... and potentially notify, but let's assume that notify happens internally, right? So now we're thinking about this. So this would be the observer from the design patterns books, right? The sensor here. So the sensor is observable, and then these would be concrete observers. So we say motion sensor and thermometer are both observable, so you can observe them. Okay, that's cool. What do they report back, right? When you say, let's think about this. Is that actually part? Can we get that right on the type level? So Get state sensor. Yeah, so let's say get state. Yeah, so let's put it just to get the types right. Like maybe we would say something like this: sensor, and then we have a sensor observable. No, sorry. Then we have a sensor observer, but these are. Yeah, sorry. So actually, it's here, right? So the sensor need to be able to say get state or something like this, right? And the question is what the return type is of this. Alright, let's do it this way. So the add method here and the remove method here are both void methods, but here we would have something that returns, let's say sensor data, and then we say get data, or something like that, get state or something like that. Sorry, my cat needs to get in. I'll be back. Okay, let's keep going. So yeah, so you get back some sensor data, and then it's a question of like, what is sensor data? So sensor data needs to be a different type, and what does that do? Well, the thing is that thing, that's like, let's think about this. This is going to have to be the thing that's the same across all different types of sensor data that you can get back. Similarly, as you might want to have something which is the same across all the different devices that we have. But we haven't really gotten to that point yet, so we're not entirely sure what that is. And we're not entirely sure what the sensor data is going to have to be. And I think here we might actually want to use polymorphism, as in, no, but I mean, of course, yeah. Yeah, I was going to say we might want to use inheritance, but let's leave that for now. Let's not think about it yet. Okay, let's push that off. I'm gonna run out of space here. This is gonna be tough. Okay, so let's move on. We have these devices. We've started to think a bit about the sensors. And we started to think a bit about the observer pattern, right? So we're saying that there are sensors that are observable, and when you observe them, you get some data back. And let's now think about the controlling part of the devices, right? So you were saying maybe you need the command pattern. I think that's a great suggestion, right? You need to be able to use commands. So you send commands to these different devices so that they, and assume that they invoke the commands that you send them. Cats. Okay. And here's, I think this is a pretty interesting moment, because I thought a bit about this before, and then I started thinking that, okay, depending on how you want to be able to run your commands, like let's say, let's think about it this way. Let's think about the room data structure, right? So you talked about, well, maybe there's a room data structure. So now I'm not going into this composite kind of stuff that we talked about before. Can you see? Yeah, it's visible. So if the room contains some kind of devices, right? It has a relationship with device. It sort of aggregates devices. And the question is there a single type called device in which you bundle lamps and heaters and refrigerators and switches, right? So if device is a collection of some sort, does that set of devices, are they all mixed together? Or do you separate, let's say, powerable stuff from temporable stuff, from colorable stuff, and keep these in different lists or collections, right? So like, if the room contains all the powerable stuff here, all the colorable stuff here, and so forth, then it's a much, much, much easier problem, right? Because you're not gonna have to think about it as like the visitor pattern is designed to recover lost type information, right? And I mean, that's like, it's a profound statement, because that happens all the time. Because when we take different stuff and we throw that into a collection and say, well, I used to know that this is something that's powerable. I used to know that this is something that's temporable. But now I'm just throwing them into a collection where I refer to them as devices. Right? Suddenly you've lost the type information, and then somehow you need to recover that type information, possibly, right? You may want to down the line. So that's what I'm saying. If you keep them separate from the beginning, it's going to be easier because you haven't lost the type information, so you won't have to recover it later. But we probably want to put them in the same list, right? Probably because there's a massive overlap between these different things, and constructing the room might be a bit tricky. I would assume, I mean, I'm not sure, but I think it might be a bit tricky if we do it this way, where we sort of have to know what type each different thing is. And in some sense, it would then be easier from the outside perspective, like from the room as the user, or the one who's constructing the room, from the perspective of that thing. It would probably be easier if we just treat them all as devices. So then it's interesting, because then we would say, well, actually, maybe there is this thing called a device, right? And we're not entirely sure what that is or what it does yet, right? But there's something called a device, and all of these things are devices. Lamps are devices, heaters are devices, refrigerators are devices, and switches are devices. Okay, we're not sure what it does, but we're just saying, okay, a room contains devices. Okay, so you have this collection of devices. Now, how does the user construct a command? Like let's think about it, right? It's like I'm opening like the Philips Hue app, and I'm scrolling through, or let's not think about Philips Hue. I'm opening this smart app that you're building, and I'm scrolling through my list of devices, and they're completely different devices, which I can see from their names, for example, right? I can see that, okay. I have this living room lamp, and I have this or a living room heater, let's say, right? And I want to send commands to these, but how do you display different commands, like fundamentally different commands, qualitatively different commands, like on the type level different commands to the user? How do you do that, right? So probably, here's the way I thought about it. Probably each device needs to be able to somehow tell, when asked, needs to be able to tell you or give you a way of constructing commands for that device. Something along these lines, probably something along these lines, right? So, of course, I mean, the alternative to this would be type checking. Of course you could do this with type checking, but we're trying to solve this using object-oriented principles, right? Without doing type checking, without resorting to type checking. We're trying to use polymorphism instead, okay? So I would think this is probably a scenario of the abstract factory pattern. So a device is so a device, I should put it this way, a device can give you a factory, where that factory is part of the abstract factory pattern. So it gives you a factory that produces commands for that particular device, right? So in other words, when you ask, so let's say, and actually I think this is going to have to be pluralized. So let me say this in plural. Let's say get factories, right? And it's going to return a collection. Yeah, I'm not going to write the return type here. Sorry, it's going to return a collection of of command factories. So let's say there's also a type called, oh, not a device. There's also a type called a command factory, right? Which is something that can produce commands. So, sorry, this is standard when I get going. Like I keep going over the movie limit, but okay, let's keep going, right? So, part 2. So these devices are all, devices according to this type, which means that they need to be able to respond to the message get factories, and then they need to respond with factories that can produce commands that are suitable for that device. Okay, So let's think about the simplest scenario, like the switch, right? When you ask the switch for get factories, what would you get? You would get a collection of a single factory that is a factory that can produce. We haven't designed this. That can produce powerable. Actually, this was black up here, so let me use black here. Powerable command. Which implements command. Right? So, and actually, a command factory needs to. Yeah, we shouldn't maybe put it like that, but yeah. Sorry, now I get confused about UML. I'm not sure whether there should be an arrow here, but think about it. A command factory produces commands, right? And so a device. Yeah, but then similarly, we should say a device, when asked about get factories, can produce command factories. Command factories produce commands, and an example of a command would be a powerable command. And then a command has this execute and unexecute structure, right? Where it's like, so that should be part of the interface. So let's say this is command according to command pattern, and then you have maybe execute and unexecute, right? Like do and undo. So the powerable command, of course, needs to implement the execute and unexecute, but the powerable command we give it a device, or we load it with a device, and then we can run exec and unexec. And one powerable command would probably be switch on, and another one would be switch off. Hang on, the cat's again. A moment. So I got a bit confused now. Let's think about this. Of course, we said powerable command here, but it needs to be on-off command, or it needs to be an on command, and there needs to be an off command, right? So let's think about this. An on command, yeah. So here we necessarily get a structure. So sorry, this is going to be a bit small here. I hope you can actually see this. If I put that here, is that visible? Yeah. Okay. So a command could be, let's say, let me put two things here, right? 1 and 2. One is on command, and another one is, actually let me not write command here because I'm just running out of space. So let me say on here, and let me say off here. Right? Those are both commands. But the interesting thing is, of course, that those are not just commands, but they are actually powerable commands. And powerable commands are commands. Okay? This is important because all powerable commands will be loaded with something which is powerable. So powerable commands can operate on powerables, right? And then we'll have a set of temporable commands which can operate on temperables, and a set of colorable commands which can operate on colorables. And it's this confusion around like the commands and the or let's say this disconnection, or this incompatibility between some commands and some devices. Like you can't send a let's say a colorable command to a refrigerator like that. Just like, it's not like, oh, that's fine, we'll just do nothing. I mean, you could do it that way if you want to go like a visitor pattern route. You could maybe do it that way. But it's also, you could also say that it just fundamentally doesn't make any sense, right? It's like, it's just like, it's non-applicable, right? It just shouldn't happen ever, right? So, like, such a system shouldn't be constructible. It's an impossible state. So instead, we have to divide these. We'll say, well, there's a set of the powerable commands, there's a set of the temporable commands, and so forth, right? And the key point here is then that when it's the powerable commands, they operate on things that follow the powerable interface. The temporal commands operate on things that follow the temporal interface, and then we can load them with anything that's temporal or that's powerable, and so forth. And of course, how we then get such a set of commands, how we construct such a set of commands would be by asking a particular device for the factories that are relevant for that particular device. And I say factories in plural, let's think about that. So I say factories in plural because we have this division where we don't want to say, we're sort of dividing not by type of thing, but by capability. So we're trying to avoid having to repeat the notion of powerableness across all the different powerable devices, and instead say that, well, something can be both colorable and powerable. These are two different things, right? So then the refrigerator, or sorry, let's say the lamp, for example, is both colorable and it's powerable. So if it's both, then we need to be able to get two factories, because we need to be able to get the factories that produce colorable commands, and we need to get the factory that produces powerable commands. So the question then is, like, what is actually this factory thing, right? Like, what is a command factory? And I think this is where it gets pretty interesting. Like, this is where it gets pretty interesting. Like, if you think about it as an application, right? Like as a mobile application, maybe the command factory is the interface. Is the interface where you're controlling like a slider, let's make it simple. When we're talking about powerable commands, where does the user toggle on or off? Maybe that's the command factory. So maybe a concrete command factory, so let's say a powerable command factory is the one that helps you, like it allows the user, it affords interaction with the user. It allows the user to interact with it. And when you press on, when you toggle on, then it produces a powerable command, a powerable on command, and executes it immediately. And when you toggle off in the command factory, it produces an off command and executes that immediately. So, and yeah, I mean, I think you can hopefully see how that scales across all of these different things, right? And then you have a command factory for temporal and one for colorable. And the beautiful thing about this, right, is that you can then put, again, you can forget the type information, you can forget the subtype information within the application and put all of the different command factories for a particular device within the same collection, which means that you can display them, right? It's like you can say, okay, well, this room consists of this bunch of devices. Oh, sorry, we've duplicated this device data type. So actually, let's follow that. I think this would be interesting, right? So a room contains a bunch of devices, right? So you say, okay, well, room, give me all of the devices. Okay, now I have a collection of devices. And then you call get factories, then you say, let's let the user click on one of these devices. Okay, so the user clicks one of the lamps, let's say. So the user clicks one of the lamps, okay? They're in a different view. They're now in the lamp view. And that's the device view, right? So maybe there's a way of displaying a device. And I'm not saying the UI logic should be put in these particular classes, but I'm just saying, like, maybe there's a one-to-one relationship between this class and a different class which is responsible for displaying this particular thing. And maybe then you would look into something like the bridge pattern, for example. Check out that video if you want to dive down into that. But then, so maybe then the device can be displayed, right? But the question is, how does the user control the device, right? So then you call get factories, because then you get a list of factories that are all sort of under the command factory interface. So then you display these in a list, and those are a bunch of commands, right? A bunch of command factories. And of course they wouldn't be called command factories in the application. Maybe they would be called power, right? Color, heat, and so forth, okay? And maybe you would even aggregate the contents of them, so you would put them in the same list. So like the user has like a dashboard where you can control power and you can control color, like sort of en masse. but anyways, the command factory is displayable. So then you display that, and then you get a bunch of things that you can do, like change color somehow, right? Click different colors and toggle on and off, for example. And when you do that, right? When you do that, the command factory will produce a command, right? Load that command with the device from which the command factory came. So there's that interaction that somehow needs to be solved. So like when the device is instantiating a command factory, it needs to pass itself to the command factory, so that the command factory knows what device to put inside the command. So the command then is created and potentially immediately by the factory executed, if that's the design that you want, right? Immediately executed. And if that command then happens to be a powerable on command, like an on command, when the user interacted here with the command factory, pressed on, for example, then maybe you have an on command. So when that's executed, the signal sort of falls back or follows back into the device, right, which happens to be a lamp, and the lamp is switched on or switched off, right? So I think this is actually pretty sensible for the device end of things, right? And it's fairly general, right? Which you can probably see. Like, it might feel like this is over-architecting, but I really don't think it's over-architecting. I really think it's actually, we could probably dig a lot further and increase abstraction more when we start to talk about, for example, the UI. But something along these lines probably makes sense, because you are now able to treat many different things as if they were the same when their particular details doesn't matter, right? Because what's the abstraction here, right? The abstraction is as appropriately identified by you, right? The abstraction is commands. The abstraction is the user wants to interact with this particular thing, and it can send this particular thing a bunch of different commands. But the question is, which thing can be sent which commands? Question one, right? And question two is, which of these things are collected within which different rooms, right? And maybe another thing that you might be interested in, let's say, maybe you want to be able to send commands to whole rooms, right? So then it's a question, well, what does that mean? Does that mean, can you send a command, is that, okay, what is that called? Is it the, right, so is the commands that are sendable to the room the union of all commands sendable to all devices within the room, or is it the intersection of all the commands? So in other words, if there is if you have a room of lights and one refrigerator, can you send refrigerator commands to that room, or can you only send the things that are common between refrigerators and lamps, such as, for example, powerable, so on off? Probably its union makes sense, right? So you would say, well, I'll send the off command to the room, and that will just send the command off to anything that's offable here, right? And let's not go into that, but probably you could figure out how to sort of build upon this structure to reach something where you could do that, right? And I think that would be pretty cool, actually. Okay, so in the interest of time, I mean, I've gone way over time, so we're not going to talk about sensors, but I think, right? I think there might be some overlap, not that in that you could use the same classes, right? But probably in that you could think in a similar way in regards to the sensors, right? Because it's a similar kind of metaphor, but it's not about commands. It's that there are a bunch of sensors, right, that are distributed across different rooms, and you want to be able to listen for updates from these sensors but these updates might have completely different structure. Right? So it's something similar to this, right? Where it's like, well, and we started to look at this, right, when we talked about sensor data. So sorry, I fell into this end immediately, but as you can see, like there's a bit of complexity here that you can definitely, or that's at least very interesting to unravel, right? But some time needs to be spent on the sensors here as well. But there's the sensor data, but the sensor data is like the thing that's common across all of them, which is probably not a lot, which is like, if you think about it from the device perspective, like the thing that we found that was the same across all devices is nothing more but the ability to get factories, right? To get command factories. So that's not a lot. So probably the sensor data will also not contain a lot, right? But you have to think about how these things interact so that yeah, sorry. I'm starting to go into it now in my head, but because probably it's not that strange either. You probably need to think about some kind of grouping like this as well, where it's like it's not an inherent hierarchy, right? But it's more like, well, motion sensors are sensors that can provide sensor data, or sorry, not sensor data, motion data, right? Thermometer is something that can provide temperature data, right? But like let's say a refrigerator could provide temperature data, maybe a lamp could even provide temperature data, right? So you're standardizing again. Like the question is, I guess, always like, are we grouping by kind of thing, or are we grouping by capability? And I would argue that here we should look for grouping by capability, because we're not sure about the exhaustive list of possible devices in the future, nor about possible sensors in the future. So if we can get some reusability going, that would be fantastic, right? So probably something along those lines, right? Where it's like, well, a sensor is a sensor that can provide a set of different sensor data, different types of sensor data, right? So whenever you ask motion sensor for data, or whenever you ask a sensor for data, maybe it doesn't just provide a single class of data, right? Maybe it provides a collection of sensor data of different types, where it's like, well, maybe you get some, let's think about the lamp, right? Maybe you get then some color data, and you get some heat data, some temperature data. But it's not, I'm gonna let this go, because clearly I haven't thought this through, because it's not obvious, because then you have a collection of things that are different, and then maybe we start to get in this scenario where we need visitor pattern in order to recover the lost type information. So we should maybe think about that a bit more carefully. And maybe I would start with this question. I would ask myself, what am I going to use this sensor data for? In what context am I going to use it? And actually, you started to say this when you said that it's going to be displayed / analyzed, right? So, let's leave that as an open question. We should think about this. Possibly draw some pointers from this discussion around devices. Anyways, let me wrap this up. Even if I was late with this answer again, massive apologies. I hope this helps, and at least thank you, because this was a super interesting excursion for me as well. And best of luck with the application. I hope it works out. Thanks for the question, and I'll see you around on the channel.